continue straight from previous video where we look at the calculation of dead load, live load, and now we are looking for live load with the wall. So live load with the wall and only the office side of the slab. So if I have office side of the slabs and due to the wall, so we just need to calculate the live load due to the office and the brick wall. We just ignoring the bedroom on the other sides. So it's quite simple in this case because we have done some calculations on this one, live load office side only and the wall. So if I draw this whole middle beam, which is 8 meters, which is here. On the office sides we have live load 15 kilonewton per meters. We just calculated that in our previous video where we calculated in the case of B. We calculated for office, we calculated 15 kilonewton per meter, so that's we put 15 kilonewton per meter at the office side. So if I can show you here, that is 4 meters here, that is applying UDL load on office side, which is here, and the 20 kilonewtons is a concentric load that also we calculated in the previous video, which is a concentric load 20 kilonewtons coming due to these two concentric load, that 20 kilonewtons coming on to here, which is at 4 meters, and the middle due to these two concentric load that makes 20 kilonewton here, that we calculated. So that is the C. Quite easy on this one because it's just ignoring what we are done for the bedroom live load. Now the last question is to calculate the maximum shear force and bending moments. So in this case I'm going to put everything onto the one diagram. So this is the beam, that is the steel beams, which is 8 meters. Let's start with this concentric load, which is 209.5 kilonewton and 20 kilonewtons. Where it's coming from? Because this is just these two load, and the wall will create the concentric loading here in the middle at 4 meters. So there's 209.5 it's coming from where we calculated in the first video about this one, 209.5 kilonewton. We calculated point load, so that is 209.5 kilonewtons, that is your dead load, and 20 kilonewton live load, that's we calculated in the previous video, which is 20 kilonewton, which is live load in the questions B. So that is 20 kilonewtons live load. So if I want to convert this point load, we can use strength criteria. ED is equal to 1.2 G plus 1.5 Q. I can show you where this equation coming from. Now that equation is coming from AS NZS 1170.0 on page number 15. If you are going to the section 4.2.2 in the strength criteria, we have ED for 1.2 G, G stand for dead load, and Q stand for live loads, and 1.5 Q. That's the equations I'm using it here. So if I can put it here, which is AS NZS 1170.0 2002, and in that case we can go to section 4.2.2 to find that equations. Now 1.2 times 209.5, that is 209.5 coming here, 209.5 plus 1.5 times live load, which is 20 kilonewton, so we get 281.4 kilonewton. That is the combination of dead load and live load. Now at the office we have a dead load of 21.86 and live load of 15 kilonewtons. I can show you for the office purpose in the questions A we calculated 21.86, that is 21.86 in the previous video we calculated, so that is 21.86 and 21.86 for both office and bedrooms, and then we also calculated the live load that we calculated for office live load. We calculated 15 kilonewton meters, so that is live load 15 kilonewton meters, and for bedroom live load 10 kilonewton meters, bedroom live load 10 kilonewton meters. So we obtain those dead load live load for office and dead load live load for bedroom. So we can combine both 1.2 G plus 1.5 Q, the same equation that we use it for point load in AS NZS 1170.0 2002. We can substitute 1.2 times 21.86, which is 21.86 for office purpose, this is dead load, and 1.5 times 15, that is the live load for office, that is 15, so 48.73 kilonewton per meter. Now the same concept we're going to apply here, which is 21.86 and 10. So we are substituting 21.86 as a dead load for bedroom and 1.5 times 10 for live load for bedrooms, so that is 41.23. Now if I draw one combined one, which is 48.73, which we take it here for office, 48.73, that are coming here, 281.4, that we calculated 281.4, that's we calculated here, and 41.23 coming from here. So we can have a combined dead load and live load in this case. So now we can draw the shear force and bending moment diagram. So this is the BMD kilonewton meters. And I think that is the procedure to draw the bending moment and shear force diagram. I'm not going into great detail here for drawing the bending moment and shear force diagram, but our question is to find the maximum shear force, which is 330 kilonewtons, and also asking you to find the maximum bending moment, which is 927 kilonewton per meters. Thank you very much.